in this video we are going to see a problem based on stress, strain and elongation of a rod. For that, here we have a question. A steel rod 500 mm long and 20 mm into 10 mm in section is subjected to an axial pull of 300 kilonewton. If the modulus of elasticity is 2 into 10 raised to 5 megapascal, calculate stress, strain and elongation of the rod. Now this is the question we have. Whatever is given here, I will write that in the form of data. Let us get started. A steel rod 500 mm long, the length of the rod is given, and 20 mm into 10 mm, this is the cross section area, capital A, is subjected to an axial pull of 300 kilonewton. P is equal to 300 kilonewton, that is 300 into 10 raised to 3 Newton. If the modulus of elasticity is, value is given of capital E, 2 into 10 raised to 5 megapascal. So we have to convert this. It becomes 2 into 10 raised to 5 Newton per mm square, because 1 megapascal is 1 Newton per mm square. Calculate stress, strain and elongation of the rod. So the first question is, we have to find out stress. Second is strain, and third we have to find the elongation of the rod, which is delta L. So let us try to get the solution for this problem. Solution: since stress induced in the steel rod is given by stress is equal to load upon area, and area it is given in the form of a rectangle. Rectangular cross section is there. Here width and depth of the section is also given. So width is 20 mm and depth is 10 mm. Now this rectangular cross section of the bar is subjected to an axial pull. Means if I draw the diagram, it will look in this way. Here I am drawing the 3D diagram that will explain the concept. So this is the rectangular section which is given in the problem, and this rectangular block, it is subjected to an axial pull. So here if I draw the axis, along this axis it is being pulled, and that pull is given as 300 kilonewton. Value we have already written in the data. So for this we have to find out how much is the stress which is induced in this steel rod. So here I'll say, therefore stress will be equal to load, and the value is 300 kilonewton, area is 20 into 10. So from this I'll get the stress value. My answer is 1500 Newton per mm square. This is the first answer. Next, we have to calculate strain. Strain can be calculated by using the formula of change in length upon original length, but here even change in length is unknown, so we cannot use this formula. So for strain, I would be using the formula from Hooke's law. So I'll say that from Hooke's law, it states that capital E, Young's modulus, is stress upon strain. This was the Hooke's law. From that we have got the formula of Young's modulus, which is capital E, and here this is strain, small e. So from this I can say that therefore strain will be equal to stress upon Young's modulus. Stress, it is 1500. Young's modulus is given in the problem. It is 2 into 10 raised to 5. So from this I will get the value of strain, which comes out to be 7.5 into 10 raised to minus 3. This is our second answer. Now after getting strain, the last question in this is to calculate the elongation of the rod. So I'll say that next, since strain is also given as, strain is given by change in length upon original length, so therefore this change in length is nothing but the elongation of the rod, and that elongation is equal to strain multiplied by capital L. Strain is 7.5 into 10 raised to minus 3. Length of the rod is 500 mm. So from this I'll get the answer of deflection, and that comes out to be 3.75 mm. The answer which I am getting here. So here we have seen in this video how to calculate stress, strain and elongation in the given rod.